impulse. We already know, we had been seeing about the two types of cells in the heart, the conducting cells and the contracting cells. In the conducting cells, we had been talking about the SA node, the AV node, that your SA node generates the impulse, and impulse travels down to the Purkinje fibers. When this impulse travels down to the Purkinje fibers, the heart contracts, right? But whenever this impulse is traveling down in the heart, some of the electric impulses, they can also be felt on the surface of the chest wall. That is the total basis of ECG, right? So what happens is, this electric impulses that are passing through the heart, they spread through the muscle tissue onto the surface of the skin, and we measure it there. We measure it there to study the conductance system of the heart. So what we are trying to do is to study whether the impulses are going properly throughout the conducting system of the heart. Okay? That gives us our ECG. Now when we get, how we will be recording the ECG and where we will be putting up our electrodes and other things, we'll see in the subsequent slides. Okay? Actually, rather I was really confused which slide I should put first and which slide I should put back. So what I'll do is, once I go through with it, I'll just brush it back again to just improve the sequence. Okay? Be with me right now. Okay, when we talk about a normal ECG waves, when we record a normal ECG wave, what we get is a P wave. Okay, just notice in this diagram over here, this is the P wave. Then we get a QRS complex, this peak, this is a QRS complex. Then we get a T wave, right? QRS complex actually are three waves, a Q wave, a R wave, and S wave. Okay, so actually there is P wave, Q wave, R wave, S wave, and T wave. Right? What you need to remember is P wave, QRS, and T wave. With this information right now, we go ahead, we'll just see about it. The P wave, what it indicates? It indicates that atria depolarize before the atrial contraction begins. Now, let's have the diagram again. Oops, bad color. The atria and the ventricle. The SA node and the AV node. Now we all very well know, whenever we talk about a nerve or any excitable tissue, normally this excitable tissue is in polarized state. Do you remember that? When we say polarized state, what does it mean? It means that the exterior is negative and the interior is positive. Am I right or am I opposite? Right? So this is how, that is, it's not neutral, it's in a polarized situation. Whenever we have an action potential acting on such a polarized tissue, what happens is, there is reversal of these charges. There is reversal of the charges, positivity coming out and negativity going out. This reversal is called as depolarization. Hopefully you would have, the depolarization would have been discussed somewhere in either the nerves or somewhere. But LA, it will come, or it would have already come. Are you all okay with that, depolarization part? I'll not go into how it happens, which channel opens and all those things. All you need to know is right now is it is in the polarized state and depolarization excites it. Once it gets excited, once this depolarization waves sweep across the atria, here, then the atria will contract, and that gives you the P wave is nothing but a depolarization wave that sweeps across the atria, while your QRS complex is nothing but a depolarization wave when it sweeps across the ventricle. Now you know that after the AV, there is a delay in the AV node, and after that the wave just goes down here and just travels across the Purkinje fibers throughout the ventricles. This depolarization wave, excitation wave that sweeps across the ventricle gives you the QRS complex. So these two waves, the P wave and the QRS waves, are the depolarization waves. Okay? Now do you remember that after any depolarization, the tissue has, just relax first. Just let's go in a sequence, Divya. Just be with me right now. Okay? Now, I know you would have read the slide, and immediate question comes that what happens to the atrial relaxation? Atria contracts, next the ventricle contracts. While the ventricle is, I was talking about depolarization. Any tissue that gets depolarized has to come back to its original repolarized state. Be it the atrial tissue or be it the ventricular tissue. So once the atrial depolarization, it has to repolarize. Right? While the atria is getting repolarized, your ventricle is depolarizing. Do you see the sequence? Your atria contracts, then the ventricle contracts. While the ventricle is contracting, the atria is repolarizing. Since this ventricular contraction, the QRS wave is so strong that the wave created by atrial repolarization is lost in there. Now do you understand where is the atrial repolarization wave lost? Divya, do you get it clear? Where is the atrial repolarization wave lost? Yeah, great. While the T wave is the repolarization wave of the ventricle. Does it make it clear? So always ECG will have a depolarization wave and a repolarization wave. Your P wave and QRS waves are depolarization wave. P wave is an atrial depolarization wave. QRS complex is a ventricular depolarization wave, while the T wave is a repolarization wave of the ventricles. Hopefully you can answer all the questions regarding that. Now you have the text over here. The atria repolarizes approximately 0.15 to 0.2 seconds after the termination of the P wave, and this is approximately when the QRS complex is being recorded in the electrogram. Therefore, the atrial repolarization wave, also known as the atrial T wave, it is usually obscured by the QRS. Clear? Okay? T wave, QRS, T wave. Your T wave of the atria would come somewhere here, that is lost. Okay? Now when we talk about the repolarization and depolarization wave, it's how it happens is, whenever, if we take the electrode over here and here, if you notice, we have put electrode here and here. One electrode is having the beginning of the sweep, and the other electrode is measuring the end of the sweep. So from the polarized state, the depolarization wave sweeps. When it is halfway, it gives a uprise. Right? When it reaches the second electrode, it comes back to the ground. So that is how the wave is created. Always there is a rise and a dip. Right? That is how the wave is created. Yeah. Again, same happens for the repolarization. When it repolarizes, it sweeps from one electrode to another. So when it starts from one electrode, there is a wave creation starting, and when it reaches the second electrode, it comes back to the ground. Right? So that is how is your repolarization waves and depolarization waves. Okay? There are some basic facts about ECG. When we talk about the ECG, there are these, what we are measuring is the electrical potential. Hopefully you all know in your physics that whenever we talk about the electrical potential, we have two poles. One is the negative terminal and one is the positive terminal. Right? And electricity flows from the negative to positive terminal. Right? Same thing happens in your heart. It's like you have the polarized tissue and then the depolarization wave sweeps from the polarized to the non-polarized tissue. Right? So direction of the sweep. So that is what ECG, there is vector. The term vector is nothing but an arrow in the direction of the electrical potential generated. In which direction the electric. So if you imagine, if you see this ventricle, so ultimately when the sweep of polarization spreads, if we just take the summation of these arrows, ultimate arrow comes in the direction, this direction. Do you notice that? When we measure it, you will get an arrow in one direction, that is representation of the electrical potential, and by convention the length of the arrow is drawn proportional to the voltage of the potential. How much ever is the voltage, the length indicates the voltage and the direction indicates the sweep of the potential in which direction it is going. That is the vector. Okay? When we take it in the heart, when a vector is exactly horizontal and directed towards the person's heart, the vector is said to extend in the direction of 0 degree. Yeah. Okay, let me just go back. I think so I have a diagram in there, or I missed the diagram. Okay, I think so I missed the diagram, but I'll just draw it for you. Yeah, we are here. Okay. Sorry for the bad man. Okay, if we take your heart, how is your heart? It's kind of inclined. Isn't it kind of inclined? Right? So when we talk about the electric flow, always an electric flow is measured in a particular direction. Okay? Suppose if I have an electrode here and here, if the flow of electricity in this direction, I will draw a vector that is an arrow like this, and my length of the arrow will be directly proportional to the potential, the potential difference. How much electricity is flowing, it will be directly proportional to that, and my arrow head will indicate in which direction it is flowing. Right? So when we consider the heart, we are doing the same thing. In heart again, there is a particular direction where their flow of current is taking place. Right? So we have to define what is the horizontal in heart. Whenever we do something, whenever we make an angle, we make it in relation to certain horizontal, isn't it? In normal scenario, when we consider horizontal, we consider our ground or earth as horizontal, right? But whenever we are considering a heart, we have to define horizontal, and then we will define the direction of its impulse in relation to the horizontal we have already defined. So let's just define the horizontal here. Right? So, in a normal heart, horizontal is basically, there is a missing sentence here. That's why you're not able to, probably you're trying to read this thing. Persons towards the person's left arm. If you start from the heart and towards the person's left arm, that gives you the horizontal. Right to the left arm gives you the horizontal. Okay, the direction of vector is towards the left arm. Right? That defines our horizontal. Now, if we calculate the total vector that is spreading through the heart, do you see this? This diagram over here, this circle. The 0 degree is towards the left. Right? Arrow is from the right to the left. Okay? Now, in a normal heart, the average direction of the vector during the spread of depolarization wave through the ventricles, whenever the wave of depolarization goes through the ventricles, the vector vector that is formed, that is the direction, and this is this. If you remember, if I just superimpose the heart on this, this is how the heart would superimpose. Right? Now, if I make a summation of the QRS wave that is spreading through the ventricle, the vector which I will get is this one. Do you notice this vector? That is approximately 59 degrees. Okay, so QRS vector is approximately 59 degrees. Okay, we have some other things also, you know, but I am not going into those details as of now. I want you to understand the QRS vector directions. Okay, so that is how the vector direction is defined, because spread of an impulse happens in one direction. All of you clear with that? Let's go to the ECG paper. What kind of a paper is an ECG paper? How it helps us to measure the time interval. Okay, so what happens is these impulses, whatever are generated, which creates the wave, they are recorded on a paper. Okay, so it's like because of the impulses, one pointer kind of move up and down. Okay, it's because of the electric impulses it is getting. Yeah, the plus sign is again in relation to, let me just go back to the diagram. The plus sign is again in relation to this 0 degree. You know, when we move clockwise from the 0 degree, it is indicated by the plus sign. So it is like, if we go here, no, I think so, you're right, Prajakta. I think so the plus sign indicates this 180 minus 90, 90. Yep, it's a relation to this thing. There is a clockwise reference scale vector rotates clockwise, and once it rotates clockwise to the 0 degrees, it gives you the plus 59 degree sign. Now when we go round and round here, you know, when you reach here, it gives you plus 180 degrees. Right? This plus 180 degrees, you know, it's not given as plus 180 degrees. No, it cannot be anti-clockwise, right? Because heart is in this direction. It's in clockwise 59 degrees to the 0. That's why plus sign we need it. Your heart cannot be this way. Your heart is always in this direction, and the spread of the impulse is in this direction. So your vector is directed only as this degree. Priyanshu, not 180 is not minus 90. See, okay, just be with me for a while. Let's just stop in the chat box right now. From 0 to 180, you know, in clockwise direction would be plus 180. But this 180 could also be in anti-clockwise direction. That is minus 180. Isn't it? So that is why we do not have this plus or minus sign with 180. But when we talk about, you know, if you just notice in here, that is plus 270. This plus 270 could also be written as minus 90. Are you getting it? If your vector is plus 270, or it could be minus 90. This is plus 90. Right? That is just in relation to your 0. When we move clockwise, it gives you a positive sign. When we go anti-clockwise, it is a negative sign. It's just a measure. So your probably your plus 59 could be measured as, yeah, we give it a minus sign when we go anti-clockwise from the 0. Your 0 is directed towards the left of the patient, and from the right to left, and that is the 0 degrees defined. Okay? All good to go ahead? Great. Okay, we were talking about our ECG paper. In ECG paper, what happens is, this is a total 1 inch block. When we say 1 inch, it's approximately 2.5 centimeters. Right? So, one large block. It is divided into these large blocks and there are these smaller blocks. So what exactly we measure is on this horizontal side. When we go on the horizontal side, what we count is vertical lines. Are you getting me? When we move on the horizontal side, what we count is 1, 2, 3, 4, 5, 6. We count the vertical lines, isn't it? Yes. So when we are counting the vertical lines and when we are moving horizontally, we are measuring time. Okay? When we are counting in vertical direction and when we are counting the horizontal lines, when we move in vertical direction, what we count is the horizontal lines. We are measuring the amplitude of the electric impulse. Okay? Perfect? Clear? Yeah, I want you to understand this because the sentence formation in the questions gets tricky because of these small things. So you have to be very clear with the concepts so that you can translate these sentences back into your knowledge. Okay? Now, our 1-inch graph is divided into these bigger blocks and these smaller blocks. These bigger blocks are of the size of 5 mm by 5 mm and they represent 0.2 seconds. They represent 0.2 seconds. Now tell me how much this total would represent in time. In terms of time, how much these 5 blocks would represent. 0.2 is 1 block. 0.2 seconds is 1 block. So total is 1 second. 0.2 into 5. 1 second, right? Perfect. Now let's just divide this 0.2 into the smaller block. These smaller blocks. These smaller blocks would be 0.2 divided by 5. That indicates 40 millisecond, also written as 0.04 seconds. Am I right? Okay? That makes it clear. This measurements are very important. Very, very important. Okay? Now let's see the amplitude. In amplitude, 1 millivolt is represented by 10 millimeters of height. Okay? Now whenever an ECG is drawn on this, you can measure the time taken for the contraction of a ventricle and one cardiac cycle, you can say. Time taken for one cardiac cycle, and with this vertical height of these peaks of the waves, you can measure the amplitude of the impulse traveling through the heart. So you're able to measure both the things when we see an ECG. Is that clear? Yep. So let me just make all the things clear. We'll just clear it whenever we need. Right now we go ahead. So obviously you can determine the heart rate seeing the electrocardiogram based on how many blocks this thing has covered. One complete cycle has covered. Based on how many blocks it has covered, you can count the heart rate, right? So if the interval between the two beats, for example, this is your QRS complex, then you have the 2T wave and then the P wave and the T. So if you measure from one point to another, RR, if you measure this RR interval or QQ interval, any two fixed intervals, as determined by the time calibration line is 1 second, the heart rate is 60. If you get, within 1 second, if you get 2 intervals, that means the heart rate is 60. In normal heart rate, it is usually, one RR interval is given by 0.8 seconds. That gives you a heart rate of 72 beats per minute. That is 60 divided by whatever is the measure you are getting of the 60 divided by RR interval. Are you getting me? All of you? Clear, right? It's clear, right? That is how we measure the heart rate. If your RR interval increases, if your RR interval increases, what happens to the heart rate? It decreases or increases? If your RR interval increases, your heart rate decreases. Perfect. Because it is at the denominator, always. Why do we use mathematical things? Why do we use mathematical things to understand the theory so that we don't have to stress our brains? So just keep your other things, just keep the formula in there and you understand the relation of the RR interval to the heart rate. Clear? Isn't it? Okay, it's not that difficult. Just relax and whenever we talk about ECG, just relax. People just take it two-way seriously. Okay? Now we had already seen the P wave, the QRS wave and the T wave. All of you know that. Now let's see the intervals between these two waves. I mean these all waves, let's just define the intervals, what they signify and how much is the gap and all those things. Fine? So we have this PQ or PR interval. Let's see in the diagram. When we say PQ or PR, often we get confused in the MCQs. Be very careful. Okay? Often PQ interval is also called as PR interval because Q wave is likely to be absent. Okay? So whenever it is either said as PQ interval or PR interval, it is assumed to be one and the same thing. Okay, let's see it in the diagram and come back. What we are talking about, PQ or PR. Okay, PR interval. This one. Right? This is the time between the beginning of the P wave and the beginning of the QRS complex. It is the interval between the beginning of the electrical excitation of the atria and the beginning of the excitation of the ventricle. We already know that P wave is the excitation of atria and QRS is the excitation of the ventricle. So we obviously can make this definition. We need not mug this up, right? So that is approximately 0.16 second and this is your duty to remember this. I can't help you with that. Okay? Now let's talk about QT interval. Now when we say QT interval, where are we? We're talking about QT interval. What was T wave? What was T wave? Ventricular repolarization. Okay? So QT interval, actually, it could also be given as RT interval. So be careful. Because many times Q wave is absent. So it may be written as RT interval. Right? So this indicates the contraction of ventricle from the beginning of the Q wave or R wave to the end of the T wave. So it actually gives you the total ventricular contraction. Your QT intervals or RT intervals, that is approximately 0.35 seconds. Okay? RR interval, what it gives? We already saw it. Hopefully you understand it. RR interval will help you in giving the heart rate. That's fine. That is 60 divided by RR interval. But what is R to R? What it gives? It gives your total cycle, atrial plus ventricular depolarization rate. It gives a total cardiac cycle, one cardiac cycle. Isn't it? Hopefully you understand everything now from in here. It may need a bit of revision, it may need a bit of back reference when you read the MCQs, but hopefully it makes the things clear. Okay, now let's record the ECG. We always talk about the leads, the 12 lead ECG, the 3 lead ECG, the 6 lead ECG, right? Now let's talk what these leads are. This will end our ECG. This will be the basic thing that will end our ECG. Okay, when we talk about the ECG, there was a concept given by Ethoven. Okay, that was called as, I don't know how to pronounce his name, Ethoven's triangle, and he gave a law that was called as Ethoven's law. ECG, there were 3 prime leads. When we say a lead, what does a lead means? What does a lead means? Lead means, whenever we apply, as we saw before, whenever we have 2 points, one is a negative point and one is a positive point, right? Electric current flows from one point to another, right? This pair of 2 points and this flow of current between 2 points is called as a lead. Okay? Do you understand the definition of lead? It is not a one point. It is the pair of points. Right? So, in a normal 3 bipolar limb leads, in this what we do is, if you notice in the figure over here, here there is one negative, one positive, right? And when we talk about the negative and positive, it is related to one another, isn't it? It's not something that one is negative means negative. Negativity and positivity is related to one another. Lead, it's related to from one lead to another lead. One point to another point, making it a lead. Okay? So what we do is we apply the electrodes left arm, right arm, left arm and left leg. Okay? So from from right arm to left arm, it's from negative to positive. Right? That gives you your 0 degree wala lead, that is from right to left. Are you getting me? That is your lead 1. Okay? Then we have lead 2, that is from your right arm to left leg. Your right arm is negative electrode and left leg is your positive. So that is this lead, that is lead 2. Right? Then your lead 3 is from your left arm to left leg. If you remember your left arm, which was a positive electrode in your lead 1, becomes a negative electrode in your lead 3. Are you able to get me there? It may take a while. If somebody needs an explanation, please let me know. Okay? I want this to be very clear. Okay, so that is your lead 3. Ultimately, they are related to each other because they are the 3 common points and they are just, flow of electric current from one point to another. And how do we measure this? We already know that if we just, what is that called as ammeter or something, that thing that measures the flow of current. If we just apply that thing between the 2 electrodes, it will measure the current flow between the 2. Right? Now, what Ethenhoven's law says, that this actually, this flow of current, it represents a triangle that is drawn across the heart. That triangle is called as Ethenhoven's triangle. What Ethenhoven's law says, that if the electrode potential of any of the 3 bipolar limb ECG are known, if you know lead 1 and 2, you can calculate lead 3. If you know lead 3 and 1, you can calculate lead 2. So what it says is, if you know the thing at any one, the third one can be just determined by simply adding the first 2. Simple addition will give you the third one. And you have to consider the negative and the positive signs as well. That is your Ethenhoven's law. Okay? Now, that was our, the primary, that is the basic in leads. That is the 3 bipolar limb leads. Okay, these are the 3 leads. Now we have further leads. Herein what is done? Do you notice this diagram? Is the diagram seen to you? Do you want an enlarged version of this? Diagram is from Guyton and actually I was just trying to fit in here. If it's okay, I'll explain it out here. Herein what it is done is, one electrode is placed on the chest, surface of the chest. chest. Do you see here? 1, 2, 3, 4, 5, 6. There are 6 points. There are 6 points. Right? So one electrode is placed on the interior. So what it is done in the 6-point lead, 6-point chest lead, one lead is recorded at one time. Okay, so what they do is they will apply one electrode here. This electrode is positive. And the negative electrode, that is called as indifferent electrode. The names are important, okay? That is called as indifferent electrode. It is connected to right arm, left arm and left leg all at the same time. How do they do that? Do you see the wiring over there? Right arm, left leg, all the three, what we were reading in the first leads, right? The 3 points, they are connected with the same wire, and these, they are joined together to form the negative lead. What they make sure is the wire which is used, see the resistance here? See this, if you remember your physics, this indicated the resistance offered by the, remember this? Yeah, so this resistance is same. When the 3 wires are connected, the resistance that is applied there is the same. Okay, so that is how you will be able to record point 1. Now when you record the point 2, you shift your chest lead here. Rest of the 3 leads remain the same. Then you record the point 2. Then you record point 3. Then you record point 4, point 5 and point 6. That is your 6 lead ECG. Is that clear? These are your 6 chest leads. So we already saw the basic leads, then we saw the 6 leads. How many leads are done now? Total? 3 we saw in before and 6 we saw now. So total 9 leads. Right? 6 plus 3, 9. We are supposed to see 3 more leads. What we are doing is, what we are actually doing in ECG, we are recording in all the directions, the flow of current in this direction, that direction, this direction, that, and ultimately what we'll do is, we'll put all the things on paper and we'll analyze, oh, this direction, this is the problem, that direction, that is the problem, right? So I'll not be going into the details of pathology, how we analyze that. Right now we are understanding in which all directions are we recording it. Okay? Yeah. Now we have this is the picture of your V1, V2, V3, V4, V5. What is this? This one V1 is nothing but your standard chest, first standard chest lead. Wherein if you go back to this diagram, this was your first point, chest point, that gives this kind of an ECG. This is the second point. And then the QRS wave starts becoming positive. Do you notice this? This point could be asked. Okay? When we talk about the chest lead, the first 2 have the reverse depolarization waves. It's just, it's not that heart is just sending the waves in this direction or that direction. Heart is always sending it in a same direction. We are recording it from different directions. That is why we, from one side when we see it looks like going down, from the other side when we look it looks like going up. So the first 2 chest leads, they give the reverse wave. Okay? Rest of the chest, they give the positive waves. All clear till here? Then we have 3 more ECG leads that are called as augmented unipolar limb leads. Okay? In the first 3 lead, what we saw was one limb, other limb, left arm and right arm as one lead. Herein what happens is, I'll just draw the diagram. Herein what happens in augmented unipolar, these were the 3 points. Right? So herein what they do is they connect any 2 limb to negative. positive, right? And lead is recorded between these two. Are you getting me? Such kind of three combinations are made. Such kind of three combinations are made. Like if I, let me use another color. Let me use a pink color. If I just fix these two to negative and this one to positive, correct? That will be one lead. And if I put, let me use one more color, these two to negative and this one to positive. Are you getting me? This kind of a lead is called as augmented lead. All of you clear? Great. Okay, so in this type of recording, two of the limbs are connected through the electric resistance to negative terminal, and the third limb is connected to the positive terminal. Now which lead is called what? Now next thing is that, defining it. Positive terminal is on the right arm. The lead is known as AVR lead. Okay? When the positive, this one, this green one is called as AVR lead. When the positive is on the left arm, it is called as AVL lead, and when it is on the left leg, it is called as AVF lead. All clear? Great. So this is how the AVR, AVL and AVF, in AVR again we get a reverse impulse. Fine? And this is the total picture of your 12 lead EKG or electrocardiogram. Your first three leads, this is the lead 1 recorded. This is the lead 2 recorded, this is the lead 3 recorded, then you have AVF, AVL and AVR recorded, and then you record V1, V2, V3, V4, V5, V6. That gives you your 12 lead EKG. Actually you record it in a continuation for some number of beats, and then you get those 12 readings, and then you analyze the ECG. Does that make it clear? And what we saw, the first basic ECG, usually is the one of L1, or it is a common waves, general waves. That is a general thing which we consider. Usually in questions they do not mention particular lead or something. Yeah, it needs a revision. Definitely it needs a revision. But hopefully that makes little bit things about the ECG clear. You can come back to me with the questions, and I would rather suggest do it today itself and solve the MCQs based on it. We usually tend to neglect the MCQs of ECG. During my preparation time I left ECG. And now I realize that was a stupid mistake from my end. Yeah, even cover up here. Yeah, that's nice. It needs a bit of push. That's the basic what I covered. There are many other things. For example, you'll be talking about inversion of that wave, increase of ST time, decrease of this time, and all those things, right? Those will come up across when you read the pathology part, general medicine part. But if you understand what it is, at least you'll be able to always relate it with the diagram, and it will be easy for you to remember those things. So all this was just the basics of ECG, just for you to understand what exactly ECG is and how it is recorded and why it is recorded that way. Okay, it rather took me more time than what I expected. I thought we'll be able to cover up in 1 hour. It actually we just dragged it for the whole class. Okay, so should we end up the class here? It should be enough. That's what you just solve back the MCQ. Solve back the MCQ. Yeah, thank you, Soumya. You will be able to realize that what more is needed. The basics would be definitely enough for you to understand any back reference reading. Now if you just pick up any paragraph from any place in the book, you don't have to read the whole chapter back. You will be able to grasp that particular point which you refer back because of MCQ. Thanks, Priyanshu. It's great if it's benefiting you all. Yeah. You all are welcome, and you're welcome to send the doubts if any. It was off the track class. I don't know, there were not much of the attendees today. So hopefully the recordings would be available for all of them to view it later. That's nice, Priyanshu. Yeah, GVP is, it's once you create it with the cycle, it's really fun to read JVP. And now, when you read it for this pathology, it's even more fun, how the mitral valve stenosis will push back, or how the valves will do to JVP and all that. Thank you all, and all the best. And probably, I'll just push in myself again in the CVS pathology or general medicine, although general medicine would not be taken by me. But, I'm trying that I take up your at least CVS pathology class so that we can relate it with the physiology. I'm not good at everything, Rajita. I'm just picking up the things. Yeah, surely we can have, Soumya, but the thing is that even, I'm not master of everything. I need to be prepared, when I'm prepared for your questions, I would rather explain them better. So, it's not that, even ECG, EKG stuck onto my mind. Before every class I need a revision and all those things. So you can actually send me the questions, and I definitely will make sure that, I am prepared and get enough data and proper data. No, Soumya, don't read the diagrams first and then solve the MCQs. Keep your MCQs aside you. I would suggest a back reference, Yeah, sure, we can have, it gets clearer with more discussion, definitely. But I would suggest do one thing first. Today, just go back and read the MCQs. Read the MCQs, refer back, and pick up the queries. Pick up the points in the areas that needs more explanation. I don't say that you need to send me the whole MCQ for me to, solve back your queries. Even if you give me, okay, this certain area needs more clarification, I can, come back with the explanations. Because I need to organize the class. If I open a blank blackboard and if I say, okay, let's start discussing, that would actually lead nowhere. Right? Yeah, we will, land up in talking about, how much you read and how much I read. And let's just be a bit more focused. So I would rather suggest cover up your MCQs and keep your laptop open with you all, Just keep typing them in a Word document. And yeah, Soumya, we will be doing MK questions. That's our total revision strategy, We cover at least we cover 2 papers, 3 papers per subject in the revision sessions. We will be having a whole revision drill later. Right now, our target is during your MDS 2012 series, we want the theory portion, the basics to be covered up. So when you read the MCQs, you will be able to touch upon more of the things. When we go to the revision session that starts after your MDS 2011, that will be a total round based on MCQs. That will be a retrospective discussions. Right? And what we usually plan up is many a times we introduce different faculty for the same subject's revision. The purpose is, different faculty would introduce some more extra points to you. It's always human, when I read a chapter, I pick up certain points. When somebody else reads a chapter, he picks up some other points, right? So many a times, my CVS class, the revision class taken up by Dr. Bhavna, or Dr. Bhavna's CVS class, revision class taken by Dr. Sagar, or we just put in Dr. Pawan's class and all those things. It will keep happening, right? The basic thing is we need to have the concepts clear, and we need to then decorate it with all the information we get from everyone. Okay? So be open to knowledge from anywhere and everywhere. Topics. These are topics. That's true.